Hello everyone, I'm Kanishka Udugoda, a student of Advanced Software Engineering Master's Degree Program, which is conducted by Informatics Institute of Technology, affiliated with the University of Westminster, United Kingdom. My research project is Churn Prediction System for prepaid subscribers in Sri Lanka. This is the agenda of this video. I will start with the problem. Here I will explain problem based on three main questions. First of all, what is customer churn? Customer churn is a huge problem when it comes to business. The term churn is defined in business world as a consumer leaving a service or a product in order to acquire more benefits in the same domain. Since gaining a new customer is costly than retaining a customer, customer churn is directly affects to the sustainability of business. Second question, why telco? Nowadays, telecommunication can be considered as a necessity for people to connect with each other and do business globally. Considering corporate sector, communication is a highly important aspect as it directly involves brand reputation, productivity of the company, and overall success. Telecommunication service providing companies have built the infrastructure to transfer voice, video, words, audio through internet, fixed line, and mobile lines for the people to communicate. In the modern world digital ecosystem, telecommunication holds the foundation for communities, businesses, families, etc. to facilitate in uninterrupted connection in order to fulfill modern day people basic needs of connectivity. This enables society to use services such as phone calls, SMS, MMS, video calls, video sharing, internet, uh, etc. When considering security perspective, telecommunication is a crucial factor to ensure national security measures as well as personal security measures. Institutions such as militaries, police departments, private security agencies are highly depending on telecom sector in order to safeguard people from potential threats and communicate as well as gather information from the reliable sources. Participation is empowered through telecommunication since the remote communities could not access to vital resources because of lack of telecommunication. With the telecommunication, larger community can participate and entire society will be grown and developed with the access to the vital resources. Since the COVID-19 global pandemic, the telecommunication sector has become the backbone of almost every industry, including health, education, business, etc. Uh, Work from home was a highly rated concept in most of the countries all over the world until the pandemic strikes hard on the world. The work from home concept would have been only a concept if the telecommunication does not exist. And now the age of telecommunication, work from home concept is practicing everywhere it is possible all over the world, even a situation where the pandemic is somewhat controlled. Finally, what is the importance of churn prediction in telco? Uh, with the rapid competition between telecommunication service providers, every service provider tend to introduce creative packages not limited to data and voice in order to attract the consumers and register them into their respective networks. Main goal of increasing customer base of each company is to increase their respective incomes by increasing revenues. When considering a customer's perspective, they always tend to choose the network which provides them the best possible benefits for the amount they have paying for the services. Business planning for upcoming years is a very hard task which faced by the telco management due to subscriber churn. Since total telco business model is directly depending on the subscriber, it is very important to retain subscribers rather than focusing on enrolling new subscribers. Considering subscriber churn in Sri Lanka, uh, with the announcement of number portability launching tentative dates by Telecommunication Regulatory Commission of Sri Lanka, which is known as TRCSL, there is a huge risk in subscriber churn in near future. Hence, it is really important to detect those kind of subscribers and retain them by introducing packages and services tactically. Since the subscriber churn is a huge threat to business continuation and remain profiting, decision makers are always interested in using an accurate churn prediction system. In summary, problem can be stated as subscriber retention is a very important factor towards business continuity for telecommunication companies. Therefore, the building subscriber prediction system management can acquire good knowledge of churning subscribers and make decisions on providing more benefits to the subscribers according to the churn rate while maintaining company profit margin so that subscriber retention can be improved. These are some recent previous work that have been conducted in the research domain. Centon has conducted a research on subscriber churn, considering post-paid subscribers in Sri Lanka. Here, the technologies such as decision tree, logistic regression, support vector machines, artificial neural networks, and boosting were used. The model which had been trained using boosting technology selected as the best performing model with 83.1% accuracy. As limitations, the dataset was collected by only conducting a random survey from current telecom subscribers. This is not considering a single service provider, considering any service provider. Therefore, the data is inconsistent. It is very unlikely to possible to apply the model for real-world predictions and applications. Secondly, Tamuka and Sibanda have conducted the research on subscriber churn prediction considering prepaid subscribers. Here, algorithms such as logistic regression, decision tree, and random forest were used. The model which had been trained using logistic regression algorithm was selected as the best performing model with more than 90% accuracy. As limitations here, freely available all sample dataset from Kaggle was used, and it is from University of California. Dataset only consists inbound calls, outbound calls, and SMS details. Data component is not considered. In modern day telecommunication, the data is a very important component, but this research data is not considered. And the data set is not applicable for current local context. Pula has conducted research on subscriber domain, considering prepaid subscribers. Here, the research random forest and J48 algorithms were used. The model which had been trained using random forest algorithm performed as the best performing model with 88.6% accuracy. As limitations, here also data component is not considered in the data set, and the data set is not applicable for current local context since the used data set is taken from South African telco service provider. Ahmed and Maheshwari's research was conducted based on Firefly and hybrid Firefly algorithms. Here the target audience is not mentioned, either prepaid or postpaid. It's mostly conducted generally. The model built using hybrid Firefly algorithm was selected as the best performing model with 86.3% accuracy. Here the dataset information is not exposed. Prashant's, Deepak's and Meher's research was conducted based on random forest, logistic regression, deep neural network and RNN. Here also the targeted audience was not mentioned, either prepaid or postpaid. This also considered generally. The model built using random forest algorithm performed best among other models with 88.3% accuracy. As limitations, we can consider that the dataset is only considering call records. So the churn only can be identified or detected based on the subscriber calls. Here also the dataset is not local, hence this will be not applicable for the current context, local context. Alvis Kumar and Hapuarachi was conducted research based on C5.03 Bayesian network, neural network, and logistic regression. The model built using C5.03 was performed best out of other among the models with 85% accuracy. As limitation, here also the target audience is not mentioned, either prepaid or postpaid. This also carried out generally. And the uh, dataset only consists of 250 subscriber records, which have been obtained by conducting a questionnaire. With a critical analysis of a system in the domain, mentioned research gaps are identified. Firstly, no recent researches have been conducted specifically considering prepaid subscribers in Sri Lanka domain. Mm, the most of the researches have been carried out considering generally for both for prepaid and postpaid customers, while few of the researches have been carried out considering postpaid customers. But there are very few researches have been conducted uh, using local Sri Lankan dataset for those postpaid researches. And also most of the data in the datasets were captured using surveys, not taken from directly from the service providers, mm, which may also occur inconsistency in the final output. Hmm. Secondly, comprehensiveness of the used dataset. Uh, most of the researches have been performed only considering call records, SMS and MMS. But in current context, with the digital transformation, mobile data usage is higher than calls and SMS. Therefore, the churn is directly affected by data component as well. And other researchers have conducted using freely available dataset. This is like Kaggle. Mm, Finally, the stacking ensemble technique was never used. Stacking is an ensemble technique to obtain higher accuracies by using base classifiers with meta classifiers. This technique wasn't used in a previous research work. This is the concept map of the project. Domain technology evaluation matrices issues were explored. Mm. The shapes that have been colored in green color shows the areas that is covered in this research project. Project aim is to design, develop, and evaluate a churn prediction system for Sri Lankan telecommunication operators in order to identify churning prepaid customers and improve companies' decision-making efficiencies to overcome the churn of prepaid customers. This is the basic architecture of the system. Dataset was obtained from one of the leading telecommunication service providers in Sri Lanka, and for the proof of concept, 15,000 subscriber records were used with 21 up-to-date features related to subscriber churn to build the predictive models. As per the architecture, the dataset was pre-processed and feature engineered process was carried out to select optimum number of features to proceed with the training models. Training and testing were done according to 70-30 ratio. Here, random forest classification and regression trees, k nearest neighbor, naive Bayes, and logistic regression algorithms were used for the model training. Here, the stacking technique was conducted using classification and regression trees, k nearest neighbor, and naive Bayes algorithm as using layer 0 algorithms and logistic regression algorithm as meta classifier. Here, bagging ensemble technique also performed with classification and regression trees algorithm. Cross validation is used, and finally, best performing algorithm was selected based on the evaluation results. For implementing the prototype, 3-tier architecture system is designed. RStudio was used to build R models with the character package. Jupyter Notebook was used to build Python models with the Scala packages. Here, the reason for performing same process using two different packages with two languages is to confirm and identify the best performing model without any hesitation. Uh, if you can obtain the same best performing model in both the methods, so you can confirm the best performing model without any hesitation. Here, Python pickle was used to save and load models. Flask framework was used with HTML to implement the web and integrate web with the created Python models. Here, Visual Studio IDE was used to implement the presentation tire. Random forest algorithm has performed as the best performing model among the other models with 90.11% and 89.1% accuracy respectively with R and Python models. Here the Backcard model performed second best, and stacking model performed as third best in the process. Uh, Confusion matrix was used to as the evaluation matrix. Uh, Precision was obtained as 96.1%. Recall was obtained 89.79%, and F1 score was obtained as 92.79%, which means the best performing predictive model is performed near perfectly. Considering AU ROC curve, it can be considered as a good model since the curve is starting from 0 whole a positive rate, and it as soon as catching up nearly 80% of uh, true positive rate and increasing gradually towards maximum true positive rate. Evaluation feedbacks are taken from 5 expert panels. Expert panel consists of one beginner developer, two domain experts, one technical expert, and one researcher. Detailed expert feedback can be found on the research project thesis. As a summary, all the evaluators provided satisfactory feedback for the design system. Let's proceed with the demonstration. Here, this is the implemented user interface for determine prepaid customer churn. These are the features that we are using to predict churn, and using the random forest, card stacking, and logistic regression, you can select the algorithm to predict. But since the random forest is identified as the best performing model, I'll show a demonstration uh, uh, predicting a subscriber churn with the random forest. This is the data set. It's a finalized feature selected data set we are using. And most importantly, this is the churn status column. 0 means subscriber is not churned. Uh, 1 means the subscriber is churned. Let's use these feature data and fill out for our interface, and let's see how the prediction works. Prediction age, distinct numbers, weekly recharge. Right, let's see the prediction. Alright, it shows the subscriber is not churning. According to the real dataset, it is true as well. The subscriber is not churn. Let's try a churn subscribers data and see the prediction. We can go back to home, do the same. We'll copy the values as before and see how will this perform. Let's see. I chose the subscriber is churned. According to this, it is true as well. So we can do the same using other models as well. It takes some time to load the model. From the backing card model, it shows churn as well. From the stacking model, we'll see shows the same, and we'll see with logistic regression, I churn it shows as churn, so it's a fault result. Since the logistic regression gives the lowest accuracy, it shows incorrect result. Let me quickly go through the code segments. First of all, a feature selection. The features were ranked according to the importance by using a random forest algorithm, and from this method I was able to identify 5 less important features. For going forward, I used all the only important features only. This is outlier analysis. uh, and this is stacking. Here the old models are trained using 7 to 30 trained to a test ratio. Here for the base models, KNN, naive bias, uh, decision classification and regression trees were used as base classifiers, and logistic regression was used as a meta classifier. And this is random forest. Here also the same the ratio, the logistic regression, same thing, and Benning cart. Let me go through the my R models. Here these are my R models, and these all here also 7 to 30 ratio was selected, and these are the bottom layer algorithms, and logistic regression was used as the meta algorithm, and random forest same process, logistic regression, Benning cart, k nearest neighbor, and bias, classification and regression trees. And this is my implementation. This is my home page where the inputs are given, and this is my output page where the churn and non-churn shows. This is my business logic. Flask. This is implemented on Flask framework. Yeah, that's all. Limitations and future enhancements. There were various issues and limitations throughout the project, from the research topic selection to the final documentation. The majority of them were with less effort, while others required more work. Limitations are identified as predictive models were trained and tested on a single machine. It is preferable to test the models on multiple machines with varying specifications in order to gain a good insights of their performances. Second one is only one data set has been used for testing, training, and evaluation. Um, Here, to get a clear measurement of the implemented system accuracies, it is preferable to have a different data set with preferably from a different service provider. But here, a single data set has been used. Here, time is another key limitation in this research project. Batch Excel upload and batch predictor feature couldn't be developed implemented due to time limitations. Considering future enhancements, even though the system has been developed as designed, there can be other improvements as well. Accuracies of the models can be improved using a big data set. It's one. Uh, Notification mechanism for customer care department can be implemented based on the obtained predictions by performing batch Excel upload and processing the file. Another one is reporting component can be developed based on the results gained from the batch Excel upload processing. And a bot can be deployed for collect data from ETL extraction, transform, in load, uh, to automate churn prediction process and connect to customer care notification platform. Conclusion. Conclusion can be discussed using these four topics: new skills acquired, use of existing skills, problems and challenges faced, contribution to body of knowledge. Consider new skills. Throughout the research duration, I've learned continuously in order to conduct research and implement proof of concept successfully. Some of the skills that I've gained during research project can be discussed as first one is Python. Although I've learned the basics of Python during the curriculum, I've self-taught advanced techniques of Python for implement predictive models and implementing the prototype. Another thing is Flask. Flask is a framework that I've never used before. This framework is used to create web applications. This being self-taught by me in order to implement the graphical user interface of the prototype. Considering existing skills throughout the master's degree program, I've gained several skills that is applied for the completion of this research project. Some of them can be discussed as one is machine learning. I've learned basic principles and some advanced techniques of machine learning during the study of data mining and machine learning module. Another one is R. R language also learned to fulfill the requirement of passing data mining and machine learning module. Basics of Python also I learned in this module. Considering problems and challenges faced, since the churn is predicted concerning Sri Lankan subscriber, it was hard to find legitimate dataset from telecommunication service provider after a few discussions with the management and few resource persons. Dataset was obtained. Accuracies of the model were drastically decreased after removing outliers of the features. To mitigate that, dataset was only performing feature engineering and pre-processing without outlier removal features. Another one is for performance evaluation. There were no many resources to train the models. Performance evaluation is done based on results gathered using a single laptop. Another problem faced was difficulty to obtain time slots to conduct interviews of the experts for requirement gathering. Another issue was it was hard to work on the project due to prevailing situation in the country with continuous power cuts, queues for basic commodities, etc. due to the economic crisis. Considering conclusion for body of knowledge, there is when considering technology, there is no existing work has been done to build churn prediction model using stacking ensemble techniques. In this research, stacking technique is used to obtain accurate model alongside with other technologies in order to compare the accuracy. When considering domain, here a legit dataset is used from a reputed mobile service provider, call records, data usage, value-added services, complaint, etc. to build churn prediction model. This model will be very helpful for the management of telco operators in Sri Lanka for decision making, especially to address challenges that will be occurring with recently launching mobile number portability service. That's it. That's the end of the presentation, and thank you very much for spending your valuable time to listening to it. Thank you.